Okay, and finally, number 26 of the trig review. Find the exact value of these combinations, cotangent of sine inverse, cosecant of cosine inverse, and secant tangent inverse. So we got to draw some triangles here. Pretty much the only way we can do these things, especially if we don't have exact values. Some of these might be exact values, but they don't have to be. So the best way to do it is draw them out. Okay, so some of these are exact, look like they could be exact values here, but I don't know about that one. So just draw them all out. That's the easiest way. So number 26, A. Let's get this down so we can see it. So the cotangent of the angle, remember we said that when you read this, that's the sine inverse. This is an angle whose sine is negative the square root of 2 over 3. Now we know that the inverse sine it exists only in two quadrants, either 1 or 4. Since it's negative, it's positive in quadrant 1, negative in quadrant 4, it's got to be in quadrant 4. Okay? So only in those two quadrants, because that's the domain. So it's either in quadrant 1 or quadrant 4. Quadrant 4 it's negative, so this is negative, so it's got to be in quadrant 4. So when I draw my triangle, I draw it in quadrant 4. Something like that. That's not the best axis, sorry about that. So it's going to be like that. This is my angle theta. And the sine is the opposite over the hypotenuse, so that the opposite will be, this will be the negative, because the hypotenuse is always positive because it's going in the outward direction. So let's just double check that. Is the sine of this angle negative the square root of 2 over 3? Yes, because it's the opposite over the hypotenuse. Now for the cotangent, we need the adjacent over opposite, so we need to find the adjacent. So once you do that, you just use your Pythagorean theorem. We can call this x. We could say that x squared plus negative square root of 2 squared equals 3 squared. So x squared plus 2 equals 9. X squared equals 7. X equals the square root of 7. Okay. So the cotangent of theta equals the tangent is the opposite over adjacent, so adjacent over hypotenuse, so it's going to be the square root of 7 over the square root of 2. That's a negative, so I can put the negative in front. And that looks a little odd, so I'll probably rationalize that. So I'll just multiply the top and the bottom by the square root of 2. And that's going to be negative the square root of 14. Can't get a perfect square out of that. All over 2. Okay. So I've got to draw some triangles, the easiest way, because this is definitely not an exact angle. Okay, let's take a look at B. Cosecant of the angle whose cosine is negative the square root of 3 over 2. Now we could kind of figure this out, that this has got to be like, looks like it'd be a pi over 6. So it looks like it's going to be, because it's going to be in the second quadrant, it's probably going to be 5 pi over 6 because it's negative, and cosine's going to be in the first or second quadrant. So you could kind of think about it like that, but it's probably safer just to draw triangles, because you can think it out that if you're real intuitive about this stuff, but otherwise, just play it safe and draw a triangle. So I know the cosine is going to be it goes from 0 to pi. Okay. And it kind of exists in the first quadrant or the second quadrant. I shouldn't have put that over here for pi, but the second quadrant over here. Okay. So it's I guess best to say it like this. This is the first quadrant and the second quadrant. And I should have done that up here for the first and fourth quadrant also. Okay. It's going to be in these two quadrants. It's going to be positive here and negative here. So since it's negative, it's got to be in the second quadrant. That's basically it. So I'll draw my triangle and see if it satisfies what I'm asking here. In the second quadrant, this would be theta. And the cosine is the adjacent. Okay, so I drew this, and since I'm going left, it's going to be negative. So is the cosine of this angle negative the square root of 3 over 2? Yes. So it satisfies that condition. So now we have to find the opposite. Okay, so let's find the opposite angle here. So let's figure out what this is going to be. So we have to use the Pythagorean theorem. So I'll call this y. So I'll say y squared equals 2 squared. Okay. So y squared plus 3 equals 4, because the square root of 3 squared is 3. Then if I subtract 3, I get y squared equals 1. So y equals 1. So that was pretty easy. So this is equal to 1. So there's all my sides. So this is relative to theta. This is the opposite, hypotenuse, and adjacent. Okay. So the cosecant is 1 over the sine. So the sine is the opposite over the hypotenuse. So it's hypotenuse over. That's how I remember it. Hypotenuse over opposite. Okay, because the sine is the opposite over hypotenuse, right? And the cosecant is the reciprocal of that, so hypotenuse over opposite. So what's my hypotenuse? Hypotenuse is 2. And the opposite is 1. So it's just 2. That was nice. Okay, so the answer is 2. Okay, and we got one more. Get some paper here. Bring out paper here. There we go. And this is going to be C. So the secant of the angle whose tangent is the square root of 3. So this is positive, so we know the inverse tangent is just going to be in these two quadrants, 1 and 4. Here it's positive, here it's negative. So it's got to be in the first quadrant because it's positive. So we'll just draw our triangle over here. This is my angle theta. Okay. And it says it's going to be the square root of 3, so it's going to be the opposite over the adjacent is the tangent. It's going to be like the square root of 3 over 1. So there's my opposite adjacent, and we're going to have the secant. The secant is one of the cosines, so I'm going to need the hypotenuse over the adjacent. Okay, cosine is adjacent or hypotenuse, so secant is the hypotenuse over the adjacent, so I'll need that. So I need to find the hypotenuse. So we know that 1 squared plus the square root of 3 squared equals h squared. So 1 plus 3 equals h. So 4h squared equals h squared. So 2 equals h. And the adjacent or the hypotenuse, the hypotenuse of the adjacent will be 2 over 1, which is just 1. I'm sorry, what am I saying? 2. 2 over 1 is 2. So there you go. So that worked out pretty nice. Is that okay? Any questions? Send me a notification, but I think that should be all right, and we'll go over these in class when I get a chance. I will. If you have any other questions, you could ask me, but this should be pretty straightforward.